About the three broad domains in which we think about the application of AI. One is, of course, cognitive work and knowledge work. That's bread and butter for us, and it's, I think, where, starting from coding to general knowledge work to business process work is where a lot of, I think, everyday use products today already are mainstream. But the other one is physical. That's all the robotics domain, the autonomous domain, the drones and what have you. It's the real, because after all, with these multimodal models with real world prompting essentially, right? I mean, if the world was the prompt, what does a real world model do? And that, I think, is another area. And the third is science, right? So when I think about science, there's two issues, right? What is the core of science, which is, up to now, the way we have been able to deal with it is by doing simulations, right? We are all, like, HPC as a category was fundamentally born underneath scientific simulation. But it turns out that to simulate nature, right, on a one-diamond architecture, you just have approximations. There's no such thing as a perfect simulation. That's why we are very, very excited about even quantum, because ultimately, the quantum computer is the real breakthrough at utility scale when you really think about simulating nature. But AI is about reducing that search space, right? So you want to discover a new material. AI can help, in fact, speed up the HPC compute by coming up with the candidates much better to simulate. So that is where we're seeing, right? So we have essentially these models that are derivatives of transformers,
exactly,
right? Like matter gen or what have you, which do have, like, one of the things is you can give it some inductive bias, right? You don't have to start without any knowledge. You can sort of think about these model architectures that do have some inductive bias. So there is a variety of models now that you can sort of get to on Foundry, which are for different domains. Biology being the hardest, after all. But I think when it comes to computational chemistry and material science is where I think we'll see rapid progress. And you saw that. We went and produced with the Pacific Northwest National Lab a new material that reduces lithium content in a battery, right, by 70% or what have you. And we went and fabricated it all the way. So that type of stuff, which, by the way, would be great, like in data center, we talked about cooling. You'll see us do some very innovative work in that domain, using these models to discover new materials that then are going in to help us, in fact, with some of the challenges we have around power.
Great. So I think moving up